Rounding errors, upper and lower bounds. In video 2.11 and 2.12, these show rounding to a certain number of decimal places or significant figures. So finding the upper and lower bounds is the opposite process. So finding out how big the upper bound or how small the lower bound the number could have been before it was rounded. So to find the upper and lower bounds, half the degree of accuracy used. So if a question says a number has been rounded to the nearest centimetre, you go half a centimetre above and half a centimetre below. If it says it's been measured to the nearest 100, half of 100 is 50, so you go 50 below and 50 above. Now there's one exception, and that is with discrete values. So things like a certain number of people. So in these ones you're just going half above and half below, because the number is so infinitely close that it's just easier to use that value. But when you're talking about something like spectators at a sports match, if this was 2,000 spectators to the nearest 1,000, then the smallest number that could have been rounded up to 2,000 is 1,500. So to the nearest 1,000, that would be rounded up because 5 or more let it soar. So that would be 2,000 to the nearest 1,000. But if you were to say 2,500, that would be rounded up then to 3,000. So because this is a discrete value, it's an exact number of people. It's not like 4,999.9999 people. It's just 4,999 people, or else 2,500 people. The upper bound in this case would be 2,499. So example 1, for each of the following questions, find the values between which the true limits lie. So part A, a length is given as 135 centimetres, correct to the nearest centimetre. So whatever it says nearest centimetre, we then go half a centimetre above and half a centimetre below. So the lower bound would be 134.5 centimetres, and the upper bound would be 135.5 centimetres. Part B, a weight is given as 3.46, correct to the nearest, to 2 decimal places. Now in this type of question, I think the easiest thing that we can do here is if we put a 0 onto the end. So if we think we're starting with 3.460, so for a lot of us it's easier to work out that way, that if you think about this end bit as 60, then the lower bound would be 3.455, so think of it like 55, and then for the upper bound, thinking of it as 65. So we're really adding on 5 thousandths here. So this is our tens, our hundreds, our thousandths. But for me, as I said, the easiest way to do it is just to add a wee 0 on and then think of that as 60. And then 55 would be the below, the lower bound, and 65 would be the upper bound. Part C then, a time is given as 12.1 seconds, correct to the nearest tenth of a second. So I would do the same thing in this question. I would think of that as 12.10. So then your lower bound will be 12.05 and your upper bound 12.15. Those are in seconds, so let's not forget our units. Part D, T rounded to 1.377, correct to 4 significant figures. So 1, 2, 3, 4. That's your 4 significant figures. Now, sometimes people get a little bit thrown when there's a letter put into a question. So T, what does T mean? You know, what's the significance of this? Well, there isn't really a significance of a T there. It's just saying something is rounded to 4 significant figures. So we don't need to worry too much about that. So 1.377, and I'm going to put the 0 on there again. So the lower bound then, I just use LB for lower bound, 1.37. Instead of thinking of this as 70, I'm going to put down for the lower bound 65. And then for the upper bound, 1.3775. So basically, making it into 70, then going 5 below and 5 above. Now these last two, it just says 127 kilograms or 43 million. When you get a question like this, you just assume that it means it's measured to the nearest kilogram. For the lower bound, we go half a kilogram below, 126.5 kilograms, and the upper bound, half a kilogram above, 127.5 kilograms. Part F, 43 million. So we think measure the nearest million, so go half a million below and half a million above.